Okay, so we are moving on to 6.2. And 6.2 title, Radicals in Rational Exponents. In rational exponents, we're going to have exponents dealing with fractions. So, a couple of different things. This symbol right here. Hopefully if you saw that symbol, you'd say, Mr. DeLong, that is the square root. This whole thing, you'll see it you'll hear it called a radical. If there was a 5 under here, instead of calling it the square root of 5, you might hear somebody say radical 5. This is a square root symbol. But I can also take other roots. I'm going to call this A, which is going to be some number. This n right here, whatever number that is, this is what we call the index. It's what we call the index. And if you have just a square root, that index is considered to be a 2. Because the square root of 4, we don't write that 2 there, but the square root of 4 is saying what number times itself gives me 4? Well, it's 2. 2 times 2. The square root of 4 is 2. When there's no number given there, it's assumed to be a 2. I could have something that is the third root or cubed root of 8. What number times itself 3 times gives me 8? Well, that's 2 times 2 times 2, so the cubed root of 8 is 2. We got to be able to use our calculator too. On this calculator, or if you have the TI-84, the square root key is right here above the x squared. Or on your phone, it's going to have a 2 in there. But if I take this and I turn this on and I say the square root of 4, it tells me it's 2. This key right here, and you'll see this, it's under the math function on your TI-84, or you'll have an X where that little n is in our notes. So if I wanted to do the third root of 8, or the cubed root of 8, I would type 3, second, that little caret key. This is telling me to take the third root of 8, and it tells me it's 2. I could take the fourth root of 64, and it gives me a decimal because it's not even. But if I change that to the fifth root of 64, or the sixth root of 64, it's going to give me the fourth root, the fifth root, the sixth root. That's nice and even. That tells me that 6 times or 2 times itself 6 times is 64. I can take any root is the point. This A is what we call a radicand. This index here, I'm going to say that is the nth root. Because just like I did over here, I call this a cubed root, but we would say it's the third root. I did a fourth root, I did a fifth root, I did a sixth root, all of 64. This whole thing together is what we'd call a radical. So just a little vocab starting out. We are going to look at some rules now, and we are going to look at real nth roots of A. We're going to write some parameters. I'm going to say let n be an integer, so it's not going to be a fraction or a decimal. It's going to be a positive or negative number. It's going to be greater than 1. So it ain't going to be a negative number. It's going to be bigger than 1. And I'm going to say let A be a real number, because we're only working with real numbers in Algebra 1 until we get to Chapter 9. Numbers be a real number. And now we're going to make some statements based on that. If n, your index or your nth root, if this number right here is odd, meaning it is 3, 5, 7, 9. If n is odd, the index or the root is odd, then A has one real nth root. Meaning if you take the odd root of something, you are going to get one answer. I'm also going to put out right now, getting back to our rational exponents, when I have something that looks like this, the nth root of A, because that's what we're talking about with all of these, I can take this A and it is to the 1 over n power. That's another way to write this. And if you put it into your calculator, if I did the square root of 4, this index here is 2. This is 4 to the 1 over 2 power, or 4 to the 1/2 power. If you put 4 to the 1/2 power in your calculator, it is going to tell you the answer is 2. So this is what we're doing. We're going to go back and forth between these two forms, radical form and rational exponent form. And we need to be able to go both ways. And they mean the same thing. This statement, though, if n is odd, you will expect one real solution. If n is even and A is greater than 0, then A has 2 real nth roots. So if this index becomes even, I would expect 2 answers, and we're going to talk about why. And I'm going to write this again. If I have plus or minus, this will equal plus or minus A to the 1 over n. And this is what I want to think about. I'm going to go back to the square root of 4, or 4 to the 1/2 power. And the reason that I have 2 potential answers of plus or minus, because the square root of 4 is certainly 2. But couldn't it also be negative 2? Because negative 2 times negative 2 is positive 4. That's where the plus or minus comes from. My answer could be 2, or it could be negative 2. That's why I have 2 potential answers with an even root. With an odd root, though, in the cubed root of 8, you're only going to have one answer. It's only going to be 2. And even if this was a negative 8, if you put that into your calculator, the cubed root of negative 8 is just negative 2 times negative 2 times negative 2. It's negative 2. And that works because you have a positive between these two. Negative times a negative is a positive, and then you multiply it by a negative, your answer will be negative. So you're only going to have one answer no matter what, whether this is positive or negative. When you're taking an even root of a number bigger than 0, meaning a non-negative, you have 2 potential answers. Whenever this index or this n is even, you need to report out with two answers. If n is even and a is equal to 0, then a has one real nth root. You're going to take some sort of root, an even root of 0, it's going to be 0. That's all it's saying. You take the even root of 0, it's going to be 0. So one of those numbers has to be 0. If n is even and a is less than 0, meaning you're going to have a negative number under your radical, then a has no real nth roots. It has a solution, but we haven't got there yet, and I want us to put this into our calculator. If I take second square root of -4, it gives me an error. Think about what's happening. The square root of -4 means what number times itself would give me -4? The only way to get -4 using the same number is if it's 2 times -2. -2 and +2 are not the same. When this is negative and this is a 2, a 4, a 6, and you're trying to take an even root, it's going to become no real number. No real root, because these aren't the same. I can certainly take an odd root of a negative number, but I can't take an even root of a negative number and get a real solution. We can get solutions, but they're imaginary, and we're going to do that in a future chapter. Here's how we use this. Here's our example. Find the indicated real nth root or roots, because if I got an even root of a positive number, I'm going to have two solutions of a. And we are going to use this right here, the nth root of a. And I'm going to say on this one, n is equal to 3, and a is equal to -27. So what I have is the third root, or the cubed root, of -27. What number times itself 3 times gives me a -27, or you could put it right into your calculator. The third root of -27 gives you a -3. Or, in rational exponent form, this would be -27 to the 1/3 power. And your calculator will certainly do that. I could put in 3 second, that's telling me the cubed root of -27, and I'll get -3. Or I could put in 27 raised, -27 raised to the 1 divided by 3 power. That's to the 1/3, and it still tells me it's -3. This is the form we need to go back and forth from. This is radical form. This is rational exponent form. Rational exponent, you've got some sort of fraction up there. Sometimes that fraction will reduce, but you've got some sort of rational number that your exponent is. So on letter B, I'm going to say n is equal to 4, a is equal to 16. I want the fourth root of 16. What number times itself 4 times gives me 16, or I put it into my calculator. Because this is an even root of a positive number, I know that I've got two potential answers that are plus or minus. I would put that into my calculator and it would tell me it's 2. Or it is 16 to the 1/4 power, which still tells me it's plus or minus 2. If I look at C, if I have an n of 6, again, another even root, in an A that's equal to 64, this would be the 6th root of 64. And if I don't know that the 6th root of 64 is 2, I would put in 6, second, 6th root of 64, and it tells me it's 2. But again, because this is even, this is plus or minus 2. And again, if I wanted to write this in rational exponent form, this is 64 to the 1/6 power, which again, if I put that in my calculator, gives me a positive 2, but your calculator's not going to give you plus or minus 2. I have to add that, and I add that when that root is even. Here's what we're doing next. We're just going to go back and forth between radical form and rational exponent form. If I have a to the 1/nth power, we're going to let a to the 1/nth be an nth root of a. I'm going to say, and let m be a positive integer. Here's what it looks like. And now I'm going to go back from here and we're going to write it in radical form. So remember, this is my index. This is really a to the 1/n raised to the m power. And this is where rules of exponents come in. You have a power to a power. You would multiply exponents. To multiply exponents, I multiply straight across. 1 times m is m. This is m over 1, so this is m to the nth power. That's where it comes from. Rules of exponents. I can write this now as a radical. This is going to be the nth root because your denominator is your index of a, and all of that would be raised to the m power. And we want to be able to go back and forth between these seamlessly. If I'm given this, I want to be able to write it like this. If I'm given this, I want to be able to write it like this. So here's 27 to the 2/3 power. If I follow what I did up here, this is really going to be the cubed root of 27 squared. This is really 27 to the 1/3 power squared, because 2 times 1 would be 2, and that's over 3. That's going to give me, this would be my index, the 3rd root of 27 squared. And I could write it just like that and finish it. The cubed root of 27, 3 times 3 times 3. 3 times itself 3 times gives me 27. 3 squared would equal 9. I may tell you to write this. I might give you this, say write it in radical form, and then evaluate it. You could certainly put that right into your calculator and give me that answer. But if I say write it in radical form, you need to write this first. A couple more examples. Negative 64 to the 2/3 power. This is the cubed root of negative 64 squared. I'm going to skip this step right here because I don't need to put that over 1 just to multiply it out. This is my index. This is what I do to it. This is the cubed root of negative 64 squared. Well, the cubed root of negative 64, if I put it in my calculator, what number times itself gives me negative 64? Negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is positive 16 times another negative 4 would give me negative 64. This is negative 60 or negative 4 squared gives me 16. You need to show your steps. Yes, you can certainly put that in there and just get your answer, but this shows that you can go back and forth between radical form and rational exponent form, and that's what we're going to do. I can go the other way. We'll call this A and this B. 9 to the 5 halves. That's the square root of 9 raised to the 5th power. My index is here. I don't need to write that 2 there. And that gives me 243. That's what we're going to work with. We're going to be going back and forth with these. Give them a try.